Can everyone see my slides? Okay. So last class we have discussed about overflow flag, that is signed number representations. So signed number is divided into positive range and negative range. So the signed number range is within minus 128 to plus 127. So your arithmetic operation, arithmetic and logical operation result is within the range, means your overflow flag is reset. Suppose exceeds this range, your overflow flag is set. Okay. So we have discussed some examples regarding the overflow flag, both signed addition and signed subtraction. And next, IO ports details, features of your 8051 IO ports. And next is your external and internal program memory. So regarding the internal program memory, if your program code, that is the program, exceeds this particular address range 0000 to 0FF, suppose exceeds this limit, 4K limit, your program counter automatically incremented to fetch the codes, instruction codes from external memory. So this can be done by using this EA, external access pin. So it must be connected to plus 5 voltage. And another method is completely ignore the internal memory and we can store our program codes in the external memory. The size of the external memory can be 64 KB. So this can be enabled by using this EA pin. So this should be connected to ground. Okay. So let's move on to the next memory, on-chip memory, internal RAM. Actually, almost all modern variants of your 8051 microcontroller have 256 bytes RAM. Okay, the size of internal RAM is 256 and that is divided into 128, lower 128 and upper 128. Okay, and first we will see about this lower 128 RAM. So this 128 bytes of internal RAM is divided into 3 blocks. So first one is the register block, second one is the bit addressable memory, and third one is the scratch pad memory. Okay, so totally 256. Most of the microcontroller variants of 8051 or any 89C51 have 120. That is 256 bytes of RAM that is divided into 128 and 128. So first 128 is called as lower 128 bytes RAM and upper one is the upper 128 bytes RAM. So this lower one is divided into 3 parts. One is the register bank, another one is the bit addressable memory, third one is the scratch pad memory. So we will see one by one. So first, one is the general purpose register. Okay, so 8051 has 4 register banks, bank 0, bank 1, bank 2 and bank 3, and each bank consisting of 8 registers, that is R0 to R7. So each with addressing range 00 to 1F. Okay, so your general purpose register addressing range 00 to 1F. Here we have 3 register banks. Okay, so each register bank consisting of 8 register in the size of 8-bit. Okay, so 32, that is 4 register banks. Each bank contains 8 register. So 4 into 8, totally 32 bytes. So how many banks? 4 banks into each bank contains 8 register. Okay. The size of register is 8-bit. Okay. So 4 into 8, 32 bytes. So 32 bytes are allocated for this block. Bank 0 to bank 3. The address range is from 00 to 1F. So these registers can be accessed either by name or address. For example, bank 0, if you are using this R7 register in your programs, either you can mention the register name or address. Okay. For example, move A, R7. So your bank 0 was selected. So this is the one way to represent this particular instruction, that is I am moving the content of R7 to A. Another way, move A, the address is 07. Okay. So this addressing is called direct addressing. So either these registers can be accessed by their names or address, internal address. So each register is associated with one 8-bit address. Okay. Is it clear? Is it clear, students? Okay. So your internal RAM maximum size 256, that is divided into lower 128, upper 128. Lower 128 is divided into 3 parts. One is register bank, another one is the bit addressable area, third one is the general purpose area, that is scratch pad memory. Okay, general purpose area is called as scratch pad memory. So next area is bit addressable memory. And another important point is here, these registers are selected using 2 bits, that is RS1 and RS0 in PSW. Okay. So the register selection can be done by using 2 bits available in PSW, that is program status word, bit 2 and 3. Okay. So next thing is bit addressable memory. So the memory space is 20 to 2F or bit addressable or byte addressable area. So 20 to 2F. For this slot, the particular slot, internal slot, address is 20. Okay. And each bit consisting of particular 8-bit address. Okay. For example, consider this one, 1A. So this bit is D0, D0, D1, D2. Okay. So D0, D1, D2. So this 1A is the bit 2 of, that is bit 2 of the internal RAM location 23. So these are internal memory location address, and each bit can be addressed by using this bit addressable memory region. So the address of the individual bits ranges from 002. The individual bit addresses, individual bits range from 00 to 7F. So every bit is associated with one 8-bit address. Okay. Is it clear? So this entire area is called bit addressable area or byte addressable area. Totally, there are 16 locations. Each location size is 8-bit. So 16 location into 8 bits with totally 128 bits. Okay. In case of byte, 16 location into 1 byte. So each location takes 1 byte. So totally 16 bytes. So the complete area size is 16 bytes. So this bit addressable region. So first one takes 32 bytes, and this one is 16 byte. So what is the purpose of this bit addressable region? Any idea about it? What is the purpose of bit addressable region? What is the requirement? Udaya Kumar, can you answer that question?
Ma'am? Hello, ma'am.
Mm.
Can
What
you
is
hear
the
me, ma'am?
purpose of bit addressable region?
And we can easily access the bits.
Bits, individual bits. For example, in case of port 0, port 1, port 2, port 3, okay. In case of your earlier processes, that is 8086 or 8085, we can access entire port, okay. Suppose port 0 means we can access only port 0. Individual pins cannot be accessed. By using this 8051 architecture, we can access individual bits of your ports or any register. Okay. For example, consider this one. Move C, comma 1A. What is 1A here? 1A is the bit 2 of your internal RAM location 23. Okay. So I'm transferring this 1A content. This 1A can hold either 0 or 1. Okay. Is it clear? So that 0 or 1 is transferred to C. Another way of writing is 23.2. That is 23.2 is bit 2 of 23. So this is the another way of writing. Okay. So individual bits can be accessed by the user or programs. Okay. So that is the main importance of your bit addressable area in 8051 architecture. Is it clear? So suppose port 0 means we can access port 0.7. Similarly, port 1 means we can access port 1.0 to 1.7. Okay, individual pins can be accessed by the user or designer or programmer. Is it clear? Yes or no? Students? Yes or no? Okay. So next area, so this one, that is your direct or indirect addressing region, that is 30 to 7F. So the 30 to 7F, that is the memory space 30 to 7F is used as general purpose scratch pad memory. That is 30 to 7F. It's used as a general purpose memory. These locations can be read or written anytime for any purpose. So totally 128 bytes. So 32 bytes are allocated for general purpose registers and 16 bytes allocated for bit addressable area. Remaining 80 bytes are allocated for your scratch pad memory. So this can be used for general purpose applications. So totally 128 bytes. So next one is the upper 128 bytes. So these lower 128 bytes, it is lower 128 bytes, can be addressed directly or indirectly. Okay, we can access these content either direct way or indirect way. In some microcontroller, there is an additional 128 bytes of RAM which share memory address with special function registers, that is 80 to FF. So this 80 to FF are allocated only for special function registers. So these registers can be addressed directly. So each register contains direct address. So these registers can be accessed directly. So your special function register occupy upper 128 bytes of internal memory. So the addresses of special function register vary from this 80 to FF. Okay. So the entire address, that is 80 to FF, is not used by special function registers. There are some unused locations, and some of the locations are reserved for future purposes. So the special functions like your timer, serial port, interrupt system, analog to digital conversion and digital to analog conversion, and UART, your serial port communications, are performed by using this special function register. So these registers control the entire operation of 8051. So they can be accessed by direct addressing. Is it clear? So 82FF are allocated for special function register. So some of the locations are unused and some locations are reserved for future purposes. And the unused locations and reserved locations should not be used by the programmer. Okay. So it will perform some special functions like timer operation, serial port operation, and accept external interrupts and internal interrupts and serial communication. Okay. So this main role of the special function register, it will control the entire operation of 8051 microcontroller. Okay. Is it clear? Is it clear, students? Any doubts? Okay. So this is a summary of your 8051 on-chip data memory. So 00 to 1F for general purpose register, bank 0, bank 1, bank 2 and bank 3, and 20 to 2F. Sorry. So 00 to 1F for general purpose and 20 to 2F for bit addressable, 30 to 7F for general purpose RAM. So 16 bytes, sorry, 32, 16, 8. So this is the internal structure of your 8051 on-chip data memory. And these are special function registers available in 8051 architecture. So I will explain one by one. Please note it down. Students, please note it down. What is accumulator? So accumulator internal address is E0. So every special function register is associated with one internal RAM address. So the size of the RAM address is 8-bit. Okay. So what is the purpose of accumulator? Please tell me. Please tell me. What is the purpose of accumulator?
Ma'am, max data manipulations,
Yeah.
ma'am.
It perform some mathematical operation. So it perform all arithmetic and logic operation. Okay. It is a 8-bit register. It is used to perform all the arithmetic and logic operations. Okay. Please note down the points. What is B register? What is B register?
Ma'am, it stores the temporary data,
It
ma'am.
stores the temporary data. And what is the main purpose of B register?
Ma'am, max operation only, ma'am. That's
Yeah,
too.
used for mathematical operation. That is multiplication and division. So it is used for multiplication and division. And what is the next register? DPH and DPL. For B register, the internal address F0. So while doing our programs, you can represent your accumulator either by name or this internal address. Your processor can accept both the format. You can represent the accumulator either by A or E0. Similarly, B. Okay. What is data pointer here? Data pointer. See, I want quick response. I completely explained architecture of 8051. What is the purpose of DPTR? Data pointer. Please note it down. DPTR is used to hold 16-bit address to access external data. Students, please note the points. It is used to hold the 16-bit address to access external data. So it is used as two 8-bit general purpose register. It is divided into two registers, DPH and DPL. So it's a 16-bit register. It is divided into 8-bit, 8-bit. DPL is the lower order data pointer. DPH is the higher order data pointer. So mainly DPTR is used to access the elements from external memory. That is addressing external memory. So it consisting of two internal address. For higher order DPTR 83, for lower order DPTR 82. So next register is interrupt enable register. It is a 8-bit register. Actually, it is a 8-bit register. It is used to enable or disable the interrupts, both your external and internal interrupts. Please note down the points. These are very important to understand your 8051 architecture. Okay, these are very important. To enable or disable the interrupts. And next one is the interrupt priority. So this is also an 8-bit register. It is used to fix the priorities of your 8051 interrupts. It is used to fix the priority of 8051 interrupts. So using this register, we can fix the priority of your external and internal interrupts. And next, 4 ports. Each port is associated with one 8-bit address. For port 0, 80, port 1, 90, port 2, A0, port 3, B0. Okay. So there are 8-bit parallel ports used for I/O operation. Apart from I/O operation, your P0 and P2 and P3 have alternate functions. Your P0 act as a multiplexed address and data bus, and P2 act as a higher order address bus, and P3 will have alternate function for supporting your interrupts, timer, and serial communication. Up to this, any doubt? Okay. Next question, next register, PCON register, power control register. It is 8-bit register. Actually, the purpose of this PCON is using this register, we can set the baud rate for serial communication. Please note down the points. Please note down the points alone. In coming classes, I will explain these register in detail. So mainly for baud rate setting, PCON is for baud rate setting, power control register. And also it holds two user flags, 0 and 1. User flag 0 and user flag 1 are holded by this power control register. And next one is the so PCON is over. Next one is the program status word. What is program status word? What is the purpose of program status word?
It will contain status bits just like the current CPU state.
Louder, please.
It will contain status bits, ma'am. That will
it will store the flag status, and also it is used to select the register banks. So it is used for mainly two purposes. One is for storing all your flag status, and another one is it is used to select the using your register bank selection can be done by using your PSW. Okay. And next one is the serial port control. And note down the address also. It is very important while doing our programs. Okay. These internal RAM addresses are very important. SCON is a 8-bit register used to select the modes of serial communication. Please note down the important points alone. So SCON is for mainly it's a control register for controlling the serial communication. Next one is the S buffer. It is a 8-bit register. Actually, it is a single register, but physically single register, but it performs two operations. One is write only, other one is read only. So write only means it holds the data to be transmitted out of 8051 via TXT. Actually, two pins are available. TXT, RXT for serial communication. So S buffer is it's a single register, but it will perform two operations, write only and read only. So write only means it holds the data to be transmitted out of 8051 via TXT, okay? And read only means it holds received data from external sources via RXT. It's a single 8-bit register used for both transmission and reception. Next one is the stack pointer. It holds the topmost address of the stack and it is used to access the stack. What is the size of stack pointer? Please tell me, what is the size of stack pointer? 8-bit or 16-bit?
8-bit, ma'am.
8-bit or 16-bit? Some other answers? Huh?
8-bit, ma'am.
8-bit, okay. And next, timer or counter mode control register, T-mod register. It is an 8-bit register. It is used to configure two 16-bit timers. Two 16-bit timers in any one of 4 modes. Actually, it is operating in 4 modes. It is used to configure two 16-bit timer. Your 8051 has 2 timers. That is timer 0 and timer 1. So it is divided into TH0 and TL0. Okay. And this is divided into TH1 and TL1. 2 timers are available. The size of the timer is 16-bit. Okay. So 2 16-bit timers, timer 0 16-bit timer and timer 1 16-bit register. Okay. So that is divided into timer 0 lower order register, timer 0 higher order register. Similarly, in timer 1 lower order register and timer 1 higher order register. So it is divided into 2. TL, TH, TL. 8-bit, 8-bit. X represent either your timer 0 or timer 1. Is it clear? And TCON, timer control register, actually it is for multipurpose register. It gives the status of your timer flags. And using this register, we can start and stop the timer operation. And external interrupt status can be monitored. Okay. So this one is the multipurpose. And remaining 4 are timer register. TL0 is timer 0 low byte and TH0 is timer 0 high byte. TL1 timer 1 low byte and TH1 timer 1 high byte. So each one is associated with 8-bit register. So coming into the bit addressable case, in case of your special function register, among the special function register, the register IP is it? IP, IE, TCON, SCON, PCON, no, not SCON, SCON, A register, B register, PSW, and 4 IO ports, P1, P0, P2, P3. So the highlighted registers are bit addressable registers. So we can access individual pins of this particular register. Remaining are byte addressable. For example, suppose I want to access bit 7 of port 1. So move C, P 1.7. I can access in this way. So individual bits can be accessed by using this bit addressable register. So remaining all the registers are byte addressable. So that's all about your special function registers. So any doubts? Any doubts regarding this special function register? Okay. So next pin diagram of 8051. So 8051 is a 40 pin DIP IC. So many pins are multifunctional. For example, 32 pins are allocated for your IO. Port 0, port 2, port 3, and P1. So 8 into 4. So totally 32 pins are allocated for IO operation, and remaining pins, your RST, EA, address latch enable, program store enable, and XTAL, external oscillator 2, external oscillator 1, ground line, and VCC, the remaining 8 pins. So the 8051 has one power supply pin, 40th pin, and the pin should be provided with plus 5 volt DC. That is VCC is equal to plus 5 voltage. And ground 8051 provides one pin for grounding the chip. That is 20th pin. Okay. And this is for port 0. So when it is not used for IO operation, it acts as multiplexed lower order address and data bus. Okay, from AD0 to AD7. And port 2 provides, that is, it acts as higher order address bus, A8 to A15. And this will have multiple function. And this is for crystal oscillator for clock generation. So remaining pins, except your IO, program store enable, address latch enable, external access enable, and this is port 3 and crystal inputs. So next class we will see about remaining all the pins, that is your XTAL connection and concept of mission cycles, how the instructions will be executed in 8051, reset, and remaining EA, program store enable, and AL. Okay.